Welcome students. In this lecture of matrices, we are going to solve for inverse of a matrix. Inverse of this matrix. We are going to check inverse of this matrix, find inverse of this matrix using adjoint method. Now, what is meaning of that? See, first of all, if I take this matrix as A, so what I have to find? I have to find A inverse. What is A inverse? A inverse is also a matrix. It is also a matrix. What kind of matrix is A inverse? This matrix A inverse is a special matrix. It's a special matrix. Why special matrix? Because it is such a matrix which I multiply to A. If I multiply A inverse to A, okay, this is matrix A. This is matrix A and this is matrix A inverse. If I multiply A inverse to A, I will get identity matrix. What I will get? I will get 1 0 0 0 1 0 0 0 1. So here we have to find this matrix A inverse. Okay, it is a special matrix. Let us start. Let us start solving this. We have to solve, we have to get A inverse using adjoint method. It means there are more than one method to get the inverse of a matrix. Yes, that is true. We can solve for inverse of a matrix using transformations also. That is using row transformation, using column transformation. Right now, we are using the adjoint method. Okay. So see, how do I begin? I will assume A equals to 1 2 3 0 2 4 0 0 5. Now, what is the formula for A inverse using adjoint method? This I have taught you in last lecture. A inverse is given by the formula 1 upon determinant A into adjoint of A. This is the formula. 1 upon determinant A into adjoint of A. So what I will do is, first of all, I will find out the determinant of matrix A. This formula is there. I'll find out determinant of A. So determinant of A is 1 2 3 1 2 3 0 2 4 0 0 5. You all know how to find the determinant. Okay, see students, this is an upper triangular matrix. It is an upper triangular matrix. Upper triangular matrix. Why? Because all the elements below the diagonal are 0. Okay. Let's find out the determinant of this. So determinant of this is 1 into what do? You ignore this and this row and this column. So you get 1 into 10 minus 0. 2 into 5 minus 0 into 4. Minus 2 into, ignore this row and this column. 0 minus 0. What do you write? 0 minus 0. That is 0. Okay. Then you have plus 3 into, you ignore this row and this column. 0 minus 0. 0 minus 0. So the final answer you have is 10. Okay, 1 into 10. These all are 0. So determinant of A is 10. Now remember students, if you have an upper triangular or a lower triangular matrix, you can use this method also, which I am now going to teach. If you have an upper triangular or lower triangular matrix, just multiply the elements of diagonals and you will get the determinant. See, 1 into 2 into 5, 1 into 2 into 5. Just do this. No need to use this formula. Just write 1 into 2 into 5. Why? Because this is an upper triangular matrix. Okay, so just multiply 1, 2, 5. 1 into 2 into 5 is 10. The answer is 10. Okay, we could have done even that. Anyways, now we go ahead. See here. I will write here as that I will write here determinant of A is not equal to 0. See, it is not 0. Therefore, A is a non-singular matrix. A is a non-singular matrix. You see this? And therefore, A inverse exists. Always remember, the inverse will exist only when the determinant is not equal to 0. Okay, if this determinant value was 0, I would have written directly that A inverse does not exist, and the problem ends there itself. Okay, that is the end of the problem. You can't go ahead. You cannot find inverse because determinant A is 0. But now I got the answer that it is a non-singular matrix, so inverse will exist. What is next step? See, I will find out inverse by finding the adjoint first. Now you all know to find the adjoint of A, to find the adjoint of this matrix, I will have to first find the minors of all the elements. I will have to find minors of each and every element. Okay, and after finding the minors, I will have to find the cofactor of each and every element. Okay, then get the matrix of cofactor and then get the transpose of that matrix, which will be the adjoint. So let's begin. I will start writing M11, that is minor. M11, what is M11? Ignore this and this. So 10 minus 0, that is 10. Okay, M11 is minor of A11. This element is A11, its minor is M11. How to get minor? Ignore this row and this column. Then you get this determinant. Solve this determinant. 10 minus 0. 10 minus 0. So here you get 10 minus 0 equals to 10. Then M12. 0 minus 0. M12 is 0. Then M13. M13. 0 minus 0. That is 0. Then you have M21. You have M21. See, this is second row and first column, M21. So it is 10 minus 0. You see this? When you ignore this row and this column, this is the element A21. You want its minor. So you ignore the row and the column in which it is positioned. So 2305, 2 into 5 minus 3 into 0. So what you get? 10 minus 0. You get here 10 minus 0, 10, M21. Then M22, M22. 5 minus 0, that is 5. Then M23, 23. 0 minus 0 is 0. Then M31. M31 is 8 minus 6, that is 2. 8 minus 6. 8 minus 6, which is 2. Then you have M32. What is M32? This is 3 and 2. So 4 minus 0. 4 minus 0. That is 4. Then M33. M33 is 2 minus 0. That is 2. So you got these elements. Now you go for the cofactor. You will write cofactor. The cofactor elements, the cofactor, I'll write here. The cofactors of elements of A can be given as, see here, C11. C11 is, okay, first of all, I will write the formula. What is the formula? The formula is Cij. Cij is minus 1 raised to I plus j into Mij. So C11, minus 1 raised to 1 plus 1, that is minus 1 raised to 2, that is 1. 1 into M11, which is M11. So absolutely no change. Same thing. So C11 is M11, which is 10. Remember students, if I plus j, that is row number plus column number, is even, then cofactor of that element is same as the minor of that element. So C11 is M11. Next. C12. C12 is minus M12. C13 is M13. C1 plus 3 is 4. So same, even number. C21 will be negative of M21. C22 will be M22. C23 will be negative of M23. Then C31, C32, C33. C31 will be M31. C32 will be negative of M32, and C33 will be M33. So I have to now write these values. I have to write these values. These values we have already calculated. We just have to put negative sign, or sometimes same as the minor. So C12. So we have these two are M12 and M13 are 0. So these two are going to be 0. Even if it is negative, negative of 0 is 0. M21 is 10 and this is 5. So here you have negative 10 and this has 5. Okay. M23. M23 is 0 and M31 is 2. M23 is 0. So it will remain 0 only. And M31, what was M31? 2. So this will remain 2. M32 is 4. So it is negative 4. And M33 is 2. So it will remain 2. Now see, after this, what I will do? I got all the factors. I will write therefore the matrix of cofactors is given as, you write that matrix as C. And what is that matrix? You will write all the cofactors here. Okay. So see here, check here. It is C11 is 10. So you write 10, then 0, then 0, 0, 0. Okay. Then you have negative 10, 5, 0, negative 10, 5, 0, 2, negative 4, 2, 2, negative 4, 2. This is C. Now I will find transpose of C. That will be adjoint. Therefore, adjoint of A. What is adjoint of A? It is C transpose, and that is C. 10, 0, 0 will become 10, 0, 0. 10, 0, 0 minus 10, 5, 0. 2 minus 4, 2. Okay. First row is first column. Second row is second column. Third row is third column. I interchanged the rows into columns to get the transpose of that matrix. Remember students, the transpose of this matrix is adjoint matrix. Okay. Now, we have to get the inverse. What is the formula? I'll write here. We know that A inverse, see students, A inverse is 1 upon determinant A into adjoint of A. Sorry. 1 upon determinant A into adjoint of A. So here I'll have therefore A inverse is 1 upon 10. Determinant of A, what we got? We got 10. So 1 upon 10 adjoint of A. What is adjoint of A? It is a matrix and it is this matrix. See this? I'll have to write that. So 10, negative 10, 2, 0, 5, negative 4, 0, 0, and 2. So this completes the solution. I hope you followed it. So here we have another question where we have to find the adjoint of the, we have to find the inverse of the matrix, by adjoint method. Same thing, earlier also we did the same. In this question also we are finding the inverse of the matrix by adjoint method. But if you see here, this time the matrix is 2 by 2 matrix. So if it's a 2 by 2 matrix, how we will do? See, if it is 2 by 2 matrix, the things will become really, really very easy. Why? See, first of all, now you have only 4 elements. See, students, you have only 4 elements instead of 9 elements. So your job is reduced by a great deal. Let's begin. So here I will start with the answer. The first thing I write is matrix I assume to be A. So I write let the matrix be A, 3, negative 1, 2, negative 1. And then we have to find the determinant. Always, always. Whenever you are finding inverse, you will find the determinant. Why? Because if the determinant is 0, the inverse will not exist. So 3 minus 1, 2 minus 1. Now see, the determinant is 3 into minus 1 minus 2 into minus 1. So you have negative 3 plus 2. The answer is negative 1. Determinant of A is negative 1. So you will write, therefore, determinant of A is not equal to 0. Therefore, you will write A is a non-singular matrix. A is a non-singular matrix. And if A is a non-singular matrix, what will happen? A inverse exists. A inverse exists. Okay. Let us start solving for A inverse. So here we have, see, I have to find the inverse of A. What is the formula? 1 upon determinant A into adjoint of A. This is the formula for A inverse. 1 upon determinant A into adjoint of A. So we'll have to first find adjoint of A. The method for finding adjoint of A is you will first find the minors of all the elements, then find the cofactors of all the elements, then find the matrix of cofactor, then find the transpose of that matrix, which will be the adjoint matrix. So let's begin. See here, I find out M11, that is minor of this element. What is minor of this element? When you will ignore this row and this column, you are left with negative 1. So you will simply write negative 1. This is the M11. Okay. Then you have M12. M12. M12 will be 2. M12 will be 2. So here you have M12. M12 is 2. Then M21. M21. M21 is negative 1. M21 is negative 1. And M22. M22 is 3. M22 is 3. Then I will go for, see, these are the minors. Okay, now I will go for, so here I can write the minors of the elements. The minors of the elements can be given as now I go for the cofactors. So here I write the cofactors of the elements, the cofactor of the elements of matrix A can be given as follows. Students, first of all, we will write the formula, okay? What's the formula for cofactor? Cij is -1 raised to I plus j multiplied by mij. So here I have C11. See, C11 is M11. We know it is same because 1 plus 1 is 2, which is even. So M11 is -1. Then C12 is negative M12, which is -2. Then C21. C21. See, the next is C21. You see this? C21 is negative M21, which is negative of -1, which is 1. And C22 is M22, which is 3. Now what we will do, we will find out the matrix of cofactors. So here I write, therefore the matrix of cofactors can be given as C, which is, you write the cofactors of corresponding elements. So -1, -2, 1 and 3. Now you write C transpose, and that is adjoint. Adjoint of A is C transpose. You write the transpose of this matrix, which is -1, -2, 1 and 3. Transpose, you understand how to get transpose? You you interchange the rows to its columns. So first row becomes first column, second row becomes second column. This is the way you do it. So -1, -2, 1, 3. So after adjoint, now we will go for the determinant, the formula for the inverse. I'll write. We know that A inverse is 1 upon determinant A into adjoint of A. That is 1 upon -1. And adjoint of A is, what is adjoint of A? It is -1, 1, -2, 3, -1, 1, -2, 3. So this is negative sign, get it inside. So you will get 1, -1, 2, -3. This is A inverse. I hope you all followed it. It must be noted, students, that inverse can also be found by transformation method. We have found the inverse by adjoint method. So inverse can be found by total 3 methods. A inverse can be determined by, see, the first method is adjoint method. The second method is elementary row transformation method. And the third method is elementary column transformation method. So we have done, just now we have done adjoint method. So we are left with 2 more methods, which now I'm going to teach you.